right, Year 7, another video on this time solving three-step equations. Now, this content is our extension content. It's not in Year 7. In Year 7, you are only expected to solve up to two-step equations, but we did do this in class, and I just wanted to give you a video in case you found it a little bit hard and you might want to watch it at your own pace in your own home in your spare time. So let's have a look at some of the examples of three-step equations. And the only tricky thing is knowing which operation to reverse first. So, for example, in this question over here, we talked about how when you are dividing by 4, what's happened is we've started with 12m over here, then we've subtracted 4 next, and finally we've divided by 5. So if you're going to reverse those operations, whatever was done last, which is the divide by 5, we would do first. Okay, so that's one way of looking at it, is I need to reverse things. I need to reverse the operations going from the one that was done last. So the last operation would have been divide by 5. So I'll remove or reverse the divide by 5 first. The other way of looking at it is this divide by 5 blocks all the 12m minus 4. So everything, the 12m minus 4 is being divided by 5. So I'll have to move the divide by 5 first in order to then reverse the operations of minus 4 and times by 12 over here. With these questions, these two examples here and here, what I'm going to be doing is I've got multiple terms with pronumerals. So I like to go small to big. I would like to move this entire 2r term over here. And since the smaller one is here, I would like to move this entire 6k term over to here. So you'll need to combine those terms using inverse operations. And that would be my first step. With this question over here, we can see the bar or the divide by 5 only affects the 6p. So that means my minus 9 is free to move. So if it's free to move, that would be the operation I would do first. So let's go and solve all these 4 equations, starting with the first one. So like I said, I'm going to try, my goal is to get all my r terms on one side and then my answer on the other side. So that means this r term will need to move over here, and I usually choose the small one to move to the big one. So in order to know which operation to use, it's important to understand that this is a positive 2r. So on this side we have added 2r and we've also added 34. So the opposite of adding 2r is to subtract 2r. So I'll do that on both sides. And when I subtract 2r from 7r, I'll get 5r. Please be mindful of where you write your inverse operations. The inverse operations for r are written under both r terms. I don't write them under the other numerical terms, but under the relevant terms. So I've subtracted the 2r from both sides. I haven't touched this minus 11, so I'll just drop it down. 2r minus r will cancel to give 0. So all I'm left with is 34 on the right-hand side. Next, I will always leave this term attached to the r last. That always goes very last, whatever's attached to the letter, or the pronumeral. So I'm going to move the minus 11 by reversing it and adding 11 to both sides. So then I'm left with 5r on the left-hand side. This will cancel. I don't need to scribble it out. One line is fine if you like to show that that's cancelled. 34 plus 11 is 45. And finally, I'm going to reverse this times by 5 by dividing by 5. And what that gives me, let me get rid of my circle here, is that r must equal 45 divided by 5, which is 9. Example number 2. Once again, the small term moves over this side to the big term. So the opposite of adding 6k would be to minus 6k. So then on this side, I can see now that 15k minus 6k is 9k. I haven't touched the minus 36 yet, so I'll just drop it down. 6k minus 6k is 0. So on this side, I'm just left with the minus 3. Now that the k is over here, that means that I'll have to move this minus 36 to the other side. And I move it by adding 36. 36, and minus 3 plus 36 is positive 33. So I get 9k on this side because these will cancel. 9k equals 33. So I'll reverse the times by 9 by dividing by 9. and that gives me k is 33 on 9. Please be mindful of always reducing your answer. I've run out of room, so I'll have to write it here. But I would divide both the numerator and the denominator by 3, the highest common factor of 33 and 9. So it gives me 11 on 3. Change colours. All right, example number 3. Like I said before, we will reverse the divide by 5, and that means I will multiply by 5. Please notice where I'm writing the times by 5. I write it in the numerator so that you can see that a 5 on the bottom and a 5 in the top will cancel to 1. I don't like it when students write times by 5 because then I think of 5 fives being 25. So please don't do that. So let's follow that setting out. So we're left with then 12m minus 4 because this 5 and this 5 over here have cancelled. And on this side, I've got 7 5s, which are 35. And then it's a nice simple two-step equation. Add 4, gives me 12m equals 39. That's 35 plus 4 is 39. Then I'll reverse the times by 12 by dividing by 12, divide by 12. And once again, I'm getting a fraction that will reduce. So if I go and divide the numerator and the denominator by 3, I'll get m equals 13 on, just squeeze it in, 13 over 4. All right, lucky last example. This divide by 5 only affects the 6p. So that means this minus 9 is free to move. So I'll move the minus 9 by adding 9 to both sides. That will cancel those terms out, leaving me with 6p on 5 on the left-hand side and a positive 12 on the right-hand side because that's 3 plus 9 is 12. Then next I will reverse the divide by 5. This will go last. So next I'll reverse the divide by 5 by timesing both sides by 5. Notice how I wrote it in the numerator so that the 5 in the numerator will cancel with the 5 in the denominator, giving me 6p. And on the other side, 12 times 5 is 60. Then I'll reverse the times by 6 by dividing by 6. And that gives me that p equals 10. All right, Year 7, our extension work, 3-step equations. Watch this video as many times as you need to try and understand. And please come back with your questions if anything doesn't make sense.